good morning, good afternoon, or good evening. Today is Tuesday, December the 7th, or of course, Monday, December the 6th, if you are in the United States. And this is the Antrea community meeting. The agenda, we have a nice agenda for today. We will start with a discussion on the service account selector for Antrea network policies, led by Grayson, and then a conversation on the refactor for the flexible open flow pipeline led by Hong Liang. So, and then in the time that will be left for today's meeting, we will have open discussion. Therefore, without waiting, I would say let's start with today's agenda, and I will hand over to Grayson for the first topic of today's agenda. Please, Grayson, go ahead.
Okay, thank you, Salvatore. Let me share my screen first. Can you guys see my screen?
Yeah. Yes.
Okay. Hey guys, I'm Grayson. I'm going to quickly share with you guys about the feature that I'm currently working on, which is service account selector. Basically, it will allow users to use service account to select workloads in both apply to and ingress or egress rule in ACMP. So this is my agenda. First, I will talk about why we need this feature, and then the API change proposal and the implementation design. At last, during the design process, I have some questions that I want to discuss with you guys. Okay, for the motivation, first, it can help manage if pods can access to some resources easily. Like service account is basically an identity. So workloads with the same service account will usually have the same permission to access some resources. With service account selector, we could easily manage those paths, control if they could access any resources like external service or something like that. And at the same time, in a reverse direction, we also can control if some specific workloads could talk to those paths with this service account. And the second, it could help to manage cluster easily. The cluster admin could assign service accounts for a different cluster person. Then the cluster admin could use the service account selector to control this person's access permission. For example, like cluster admin want to restrict workloads created by a person, not to reach external IP. So admin can create a network policy that block traffic from the service accounts that assign to this person to external IP. So this is the motivation of this feature. Yeah, let's see the API. So as you can see, the service accounts can be used in the apply to, and we also can use it as a peer in ingress or egress. But I just used the apply to as an example in this sample network policy. So in this case, it can be used as a name and a namespace combination, or a label selector, like we used in the pod selector and the namespace selector. So in this case, all pods with those service accounts will be selected by the by this service accounts selector. Any questions so far? Okay. So about the implementation design of the service account selector, there are two key steps. So first one is, while we adding a pod, we not only just add the exist labels of this pod to our group index, but also we add another label to group index, which which is as shown here. Like first we have an Antrea reserved prefix, and about this prefix I have some question about it, like label conflict issue. I will discuss in the next part of open question. So so first is Antrea reserved prefix and the service account as key label, and then the service account name as the key value. So basically, after the pod was added in the group index, it will also have this label added to its related label item. So next step is while we processing the ACMP, we need to translate the service accounts field to pod selector and the namespace selector. For example, if we have we have service account SA-1 and in namespace NS-1. This is the service account we want to select. So after the translate, it will become one pod selector with start with Antrea reserved prefix, service account, and the label value is SA-1, which is the service account name. And with a namespace selector, we use the namespace name as the label to select this namespace, like the kubernetes.io/metadata.name, and the key the label value is ns-1. So after these two steps, all other logic is already existing in Antrea code, so it can quite mostly reuse the current code base. Yeah, go ahead.
I can understand how this works if the service account is about name and namespace, but how this works if we use
the selector
for
for the selector case, when we translate, we'll first use the label selector get all service account out. Like if we select the label is we need the level user label. There are several service account like service account 1, 2, 3. So all these service account will be retrieved, and we translate all these 3 service account to pod selector plus namespace selector.
Then it will become multiple pod selector and plus namespace selector. Right?
Yes.
It's our current code can handle this. Does it handle this?
This is during the translation. This is during the translation from service accounts to the selector, to pod selector and the namespace selector. It's new, yes.
Okay, thank you.
So the process will hold, like if you have selector, first we translate the selector to service account name and the service account namespace, and then from service account name and namespace to the pod selector and the namespace selector.
But if the service account changes, do we also change the labels on namespace and pods?
You mean service account change the name?
For example, if you're saying you can use label selector to select service account. If the labels of the service account changes when you have a new service account, do you also change the labels on ports and the namespace?
That's a good question. So you mean the service account changed its label, right? Do we need to change our? Okay, so if the label we add to the pod use the service account name, so the pod the relation between pod and the service account hasn't changed. So while we processing the ACMP, we need handle this label thing. So if the service account label has changed, we need to catch this update event and reprocess this ACMP.
Okay, so probably I missed something. So for the label on port, do you mean we don't really care the service count used by Antrea policy or not? Or you always label all the service count for a port to the port?
I'm sorry?
Do we always add the label for all the service count on the port?
Yes.
Or only when the service count used by Antrea policy?
We always add this.
Okay.
As for the current design, if you're worrying about like a performance issue or
I'm just not sure. It looks strange to user or not. I mean, if they never use service count define a policy, but we always add a label for.
Oh, this label is just inside our group index. It won't show to the user. User won't know this.
I see.
Yeah,
I see.
Just for our internal.
I see. Got it.
Any other questions? Okay. Let's go to the open question. So basically, first is, can service accounts be used with other peers? From my own opinion, I think it should be used as a standalone peer, no matter in apply to or in the ingress or egress from or to field. So from my understanding, as if you use multiple field in one peer, those fields should work like an intersection. For example, you should use namespace selector and the pod selector. You should select the pods from those namespace. But service account seems like it don't have to work intersection with any other field. So yeah, I think it should be a standalone field in the peer. And also, while I'm thinking about this issue, I find that the group in peer, which is should be a standalone peer, but the validation seems not comprehensive enough, and which will cause an issue. For example, if user use group and FQDN, the FQDN won't take effect. So I already open an issue to track this bug, and we'll open a PR to fix this. Early tomorrow in PT time zone. Yeah. So what do you guys think about? Go ahead.
I was thinking, if there is a selector support in service accounts, then how do we select? How do we specify we want service account in specific namespaces? I see only selector in your API definition, right? There is no.
Yes. Yeah, that's a great question.
For it will always be all namespaces.
Yeah, currently it is, yeah.
Is it possible
do you think it's a? Yeah, go ahead.
I'm thinking if it's possible to combine the namespace selector field with service account, like the port selector. But I know the difference.
I get your I know what you mean. Like we can support name and the namespace combination, and also namespace selector and selector combination, right? Something like that.
Yeah.
Yeah, I guess we could do that. Yeah. Let me see if it's so if user don't provide the namespace selector, we select the among all namespaces, right?
Yeah.
Yeah. Yeah, that's a great idea. I will add to my PR and the design doc to update the API proposal. Yeah. Thanks, Chen. I think it's a good idea. Yeah.
Okay. Thank you.
Yeah, thanks. Yeah, so I guess for using service accounts as a standalone peers, we have an agreement. Anyone has some ideas, feel free to bring up. Okay, so for the label conflict, as we can see, let me go back. Here we use Antrea reserved prefix here. We could use it like to try to avoid it will generate a label conflict with user own labels. I have discussed this with Chuan before. We tried to add kind of like an illegal label format for a Kubernetes server while we add the label. So basically, user cannot use this format label, and we can use it inside our group index. But turns out that it will still go through the process to validate the label format, so it cannot work. So we basically go back to use like reserved prefix, for example, like antrea.io/reserved reserved label dash service account, or other custom label that we want to use in future here. So what do you guys think about this idea? Use this prefix, but it still could generate some label conflict. But will this be an issue, or we, as long as we state this in our documentation, say this label prefix is reserved by Antrea, is enough? I think definitely we shouldn't. Definitely we shouldn't validate this if user use an illegal or conflict label with Antrea reserved prefix. It will basically have a really bad effect on our performance.
One question from me, Grayson. Is there only a performance impact, or would there also be a way for users to abuse of network policies in this way? Can, for instance, users create another service account label to violating enforcement of the network policies in this way?
I'm sorry. I don't think I understand the question.
Yeah, I mean, if the user deliberately creates a label like the one that we see on the screen here, but instead of using their service account name, they use some other service account name with different rights, are we going also to modify the way in which the Antrea network policies are enforced then?
Oh, so you mean like user add this label by themselves with
yeah, that's
like
right.
a different service account name that the pod has, right?
That's right.
So basically, if user do this, we should make while we add this label to the group index, we will rewrite the value of this label. If user want to get the pod, it will still showing that the label is what he wrote. But while we do the match, do the select, it will use the real one. But user couldn't use the they wrote the one to do the match. So this is a label conflict issue. So we are trying to avoid user use this label key. Yeah, it's a really good question. It's a valid issue that we should think about.
I think
yeah.
like the native Kubernetes namespace name label on this slides, Kubernetes.
Yeah.
I think unless people want to confuse Antrea on purpose, right? It could just work without any issue. For example, I think user can even label a namespace with another name different from its actual name, and it cannot take the namespace with this label selector. But I think this is done on purpose, not by accident, right?
Yes. By the way, if we use the the Kubernetes namespace name label, how will the Kubernetes react to this?
I think it will not have any effect unless you are using this namespace selector in the network policy rules, and you will get some surprising result that you want to select one namespace, but you match another namespace. Yeah.
Got it. I also think we can use something like this to do this label in our group index. But as long as we state it clearly in our documentation, that's enough, I think.
So it's an internal index, right? Could we use some invalid label value for that? No?
Oh yeah, that's I said I tried this before. When we trying to translate the during the translation, it will have to new requirement struct during this process, and this requirement struct will do the label format validation. So even this internal label, we still can't do that.
Okay, that is done by some Kubernetes upstream library.
Yes.
Okay.
That's all from my today's presentation. If there's no more questions, I will hand out the control.
Is there any final question for Grayson? All right, then we can move to the next topic for today's meeting, and which is the OpenFlow flexible pipeline. And Honlian, please go ahead. The floor is yours.
Okay, wait a minute. I will share my screen. Okay, let's just start. Can you see my screen? No. Just the motivation. As we can see, assume that this is not a flexible pipeline. This is current pipeline. As we can see, assume that we have 5 tables, and table B, C, D are used for function X, which can be a bool option in entry agent config file. No matter how the function X is enabled or not, table B, C, D will be initialized. And if a packet from table A it will be sent to B, C, D, E. One way to resolve the issue of redundant tables is to modify the action in table A to let the packet go to table E directly, but this requires additional judgment. If flexible pipeline, if function X is not enabled, sorry. Table B, C, D will not be initialized. The only table A and table E will be initialized. The next of table A will be table E. In this way, the packet can save steps in pipeline. This is the first motivation to reduce the redundant tables in a pipeline. The second, oh sorry, I didn't change the title. The second motivation, we can the table ID of every the table ID of every table in current pipeline is fixed. If we want to add a new table, you need to manually specify the table ID. For example, you want a table B, another table B, like table B. You need to change the ID of table C, D, E, because you need to consider receiving a certain ID interval for adding tables in the future. So we can't just specify the table ID for new table as 6. We need to leave some interval. And when using a flexible pipeline, according to the order of required tables, table ID will be automatically and dynamically generated. The table ID will be generated one by one, not leave any interval. For example, we just need table A and table E. The table ID will be 1, 2. For this one, there will be 1, 2, 3, 4, 5. Okay. And for next, we want the pipeline to be more standardized. For the flexible pipeline, all tables are divided into 11 stages according to their functions. And the red ones are related to security, like safeguard, network policy. The yellow ones are related to routing, such as SNet, DNet, routing decision. And blue stages are related to contract. The gray ones are related to layer 2 forwarding. First, what's a stage? A stage may has one or multiple tables. some principles of flexible pipeline. First, a packet from table in states can only jump to the first table of another state. And we add a new action called go to states. Another principle is that a packet from a table in states can jump to any table within these states. For example, in routing states, there are three tables. The first table of routing states can be resubmitted to the third or other tables within these stages, but the packet of the packet in this table can't be resubmitted to the last or the second, the third table in any other states. Okay, this is the principle of flexible pipeline, or basic principle of flexible pipeline. Okay, next is the design of flexible pipeline. First, the concept of feature. The concept of feature is a collection of a series of functions. Now we have 5 features. In the future, we may have more. Feature port connectivity is responsible for the network connection between ports. Feature service is responsible for service implementation. In Antrea, feature network policy is responsible for network policy, and Antrea network policy implemented by Antrea. Others like egress and trace flow. A table request. A feature must use tables to implement its functions to install flows. If a feature wants to use a table, then a table request should be made to declare that it requires the table. Multiple features may use the same table to implement their functions. The priority is a structure, is a member structure of a table request. It determines the order of a table in each state, and the highest order will become the first table in this state. A table may be declared by multiple features with different priorities. If so, the highest priority will be used. In addition, the order of stages are fixed, like this. The order of these stages are fixed, but the tables within a stage is determined by its priority. According to the priorities in every stage, the final pipeline will be generated with allocating table IDs. This is a simple example. First, for feature A, it requests 3 tables. In stage 1, stage 2, stage 1 for A1 priority 20, A2 priority 30. Table B1 priority 40. For feature B, it requires 2 tables in stage 1, stage 2. Feature C, it requires table B2C. For stage 1, for table A1, it has priority 40 and 20. 40 is declared by feature A1, feature is declared by feature B. 20 is declared by feature A. Table A2 only declared by feature A. For stage 2, it's similar, and this stage 3. Okay, now the order of stage is fixed, so we can see now we need to determine the order within the stage. For stage 1, A1 has the highest priority, so its order is the first table of this stage. And then A2. For stage B, B2 has the highest priority, so it's in first place. Then for B1, and then for C, table C. Well, that's the process of a flexible pipeline generation. For next, this is the current. This is area. Each feature is to declare some tables by default, and some tables are controlled by maybe controlled by feature flags or other conditions. For example, for this one for entry policy egress rule table, if we enable entry policy, then this table will be declared and initialized by feature network policy. If entry is a dual stack, then IPv6 table will be declared and initialized. If on Windows platform, the uplink table will be declared and initialized. Okay, this is also tables of flexible pipelines. For the next current table case, the traffic cases. In order to adapt to the flexible pipeline, some flow tables of Antrea has been redesigned. This table shows all traffic models on in-cab mode. Traffic is divided into 3 categories: service, egress, and general. Egress is also a subset of general. There are four sources: the packet sources and the file types of destinations. This means that the packet is from take this one for example. This one. This means that the case is only for request and reply packet. The packet is from gateway. Its destination is to local. Then this type of packet should go to switching stage directly. It doesn't require SNAT. Like this one, DXSR, where? DXSR. Okay, this one. This means that the packet is from gateway and its destination is external, like a node pod or load balancer. Its client is from out of cluster, and its endpoint is a host network endpoint. And this packet is forced to be assignated as its helping case, and so it should go to service helping mark table, then go to post routing stage to perform assign. Okay, I can't introduce every traffic case as time limited and time limited. Okay, this is no. Sorry, this is no cap. Okay. In order to adapt to flexible pipeline, and the flow table marked in yellow is redesigned in some degrees. For layer 3 forwarding, for layer 3 forwarding, this flow may cover multiple traffic modes. In layer 3 forwarding table, loading destination mark register operation is added for every flow. This. The advantage of increasing the destination mark register is that it's easier to get helping cases or egress traffic. For next, this is a new table added by flexible pipeline. It is used to process helping case. Now we have about three types of helping cases. First, the source may be from an external client or a Kubernetes node, and the destination endpoint is on current node, just the host network endpoint or an external endpoint. We call this internal helping case. Source mark, and we can get this connection by matching destination and source register mark. Another helping case is internal helping case. A client is from a pod and its destination endpoint is itself. We can get this helping case by matching the source IP address and the destination IP address. Okay, then IPTDR-DEC is nothing different. Okay, this is a big change about SNAT. First, the first flow, we need to match the first packet of all helping cases. And we load a city mark as SNAT reg mark as a switch. We also need another city mark. And then this city mark is on DNAT switch zone. Then the packet will be forked to this table again, and it will be matched by the second or the third flow for helping cases. For internal helping cases, this is for internal helping cases. This client is from external. It will be marked with SNAT with virtual IP. For internal helping case, it will be marked with SNAT with gateway IP address. When we use in this case, when we use the gateway IP address. As porting Windows platform, they don't reply to a virtual IP like 16. This for the reserve IPs. Okay. For this one is also an important one because these three flows are just matching the first packet for subsequent packet of isolated connections. This flow is used to master. Oh, sorry. Okay, for this flow, it's used to perform SNAT for node pod or load balancer service traffic. As we know, this this kind of traffic needs SNAT too. Okay. We can see that we for every flow to perform the SNAT, we also load a service CTMark. This is for bypass service traffic in contract commit table. We can't let the subsequent request packets to be masked by this flow. If it is masked by this flow, it will be treated as new and tracked, and will get unwanted result. Another CTMark is this one. How to handle the reply package of Harpin connections. For reply packets of Harpin cases, such as Harpin CTMark is set in SNAT sysjoin. After the packet passing SNAT contract join, the CTMark can be readable. Then the Harpin reg mark will be set, and the packet can be output normally. This flow can not only just match the reply packet, it can also match the Harpin request subsequent packets, except for the first packet. Okay, that's all of my presentation. Any question?
Thanks, Andrea. Is there any question regarding this presentation? All right, it appears there are no questions on Liang, so thanks very much for your presentation. And in terms of delivery, I think this is something that is already under development. Is that correct?
Oh, sorry.
So in terms of delivering this in Antrea, you are already working on development of the flexible pipeline. Is that correct, or is this?
Yes, it can work now, and the code can pass the Jenkins conference test and all canned tests.
Good.
But it's also have made the PR.
Okay. Are we, is the current plan to just switch to the new pipeline, to the flexible pipeline, or are we going to allow for some time to existing installations to run? I mean, like, for some time, maybe we will have both the, let's say, the old pipeline and the flexible pipeline with some feature gate, or are we just going to switch to the flexible pipeline once it's merged?
I may didn't get what you say, but
yes, sorry. I was not explaining myself correctly. I was saying once the flexible pipeline is merged into Antrea code base, will every existing Antrea installation automatically switch to the flexible pipeline, or do we need to make some configuration changes to enable it?
No, we will just override the current pipeline. We want to, I think we want to make any black flag or any other options to disable or enable flexible pipeline.
Okay. Yeah, makes sense. Understood. Thanks. Is there any other question for Wang Liang? Any other comment on the flexible pipeline design? Okay, that appears to be all then. Thanks a lot, Hong Liang. As we have still a few minutes left into today's call, is there any other topic you would like to bring up for discussion? Well, then I would say that that's all for today's meeting. As usual, I would like to thank everyone for attending, and most importantly, many thanks to Grayson and Hong Liang for preparing the presentations for today, which have been really informative and great from both from a discussion perspective and also for improvement in Antrea. So thanks a lot for these presentations today, and thanks again to all attendees. And I would like to wish everyone a good evening, a good morning, or a good afternoon. Thanks again for joining, and see you in 2 weeks' time. The next week meeting will be on December the 21st, and I don't think that we need to plan any change of schedule for end of year holidays. We should be fine. Next meeting is on the 21st, and then the other meeting will be in the new year. So thanks again, and I wish everyone a good one.
Thank you. Bye.
Thank you. Bye-bye.